All right, guys, your test is on Monday, and this covers the second half of the chapter that we did for this. If you're struggling at all with 3.1 or 3.2, remember that was graphing and substitution and elimination. Either come in today, if you're watching this early enough, or send me an email, reach out, because I want you to be ready to go for Monday, okay? For these first ones, we are graphing and shading. So I'm going to just color code a little bit for you here. This is how I'm going to graph them. So for the first one, remember we graph these like you graph a line. Even though it's an inequality, there is still a line involved here. So we're going to start by plotting that -5 first as a y-intercept. So that's going to go right here. And then it's a slope of 1. So we're going to go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay. And then use a straight edge on these, or if you're doing it in Notability, Notability will take care of that for you. My straight edge, I should really just do this in Notability, but I really like this app. Oh, I messed up. Don't do that. What kind of line is this? This should be a dotted line, right? So we're going to make it dotted because it's a greater than. Okay, so here's your line. And then remember, we plug in a point. I'm going to plug in 0, 0. So is 0 greater than 0 minus 5? Well, if you plug that in, you get 0 is greater than -5, which is true. Okay, when it's true, you shade on the side that 0, 0 falls. So we're going to shade up above because that's where 0, 0 is. Okay, and then for our second one, notice this one, you could do standard form and just do the cover-up method. I don't like that as much, just for getting an exact answer, because you end up with a fraction, but you can do it that way. It's not wrong. I'm going to put it into slope intercept. I'm going to take away 3x from both sides. So I get y is less than or equal to a -3x minus 2. So to plot that, we're going to do our -2 here, and then it's down 3 over 1. Okay, and again, I would probably do another point up this way, just so you have a good stretch of points there. This one's solid because it's got the equal to. So we're going to draw a solid line in here. Okay, and now if you plug in 0, 0, I get 3 times 0 plus 0 is less than or equal to, -2. So 0 plus 0 is 0, and 0 is not less than or equal to -2. So we're not going to graph the 0, 0 side. We're going to graph away from 0, 0, which would be this side, which means our solution is where we have overlap. So our solution is going to go, let's just do this. It's going to be all of this. Okay. All right, number 2, notice these guys. You have y is less than 4, so think of that as y equals 4, and then x is greater than or equal to -3. So y equals is a horizontal line. Oops. Okay, x is a vertical line. So if it's y is less than 4, we're doing a horizontal line at 4. Oh my goodness, it doesn't want to line up for me. Okay, forget the straight edge. So a dotted line at 4. And if y is less than 4, it's going to be a number lower. If I plug in a 0, it works. So that's going to be all of this. And then x is greater than or equal to -3. That's a solid line at -3. And if x is greater than or equal to -3, that's all of this. So my overlap right now would be all of this. Okay. All right. Sorry if you were hearing a lot of clicking. I forgot to put my earphone or my earbuds in. Okay. Number 3, we are going to graph the line y is less than or equal to x plus 2 first. So it's a y-intercept of 2 and a slope of 1. Up 1 over 1, up 1 over 1, up 1 over 1. Because we have that equal to bar, this is going to be a solid line. So it's going to look something like this. Okay. The second one, don't forget what this looks like. When we have absolute value, remember that is V-shaped or upside down V-shaped. This one is going up. So your vertex right now is the point 3, 1. So 1, 2, 3, 1. Okay, and then from there, our slope is a 1, right? When there's nothing out in front there, it's just up 1 over 1. Okay, so if we draw this in, this is a dotted line because it's greater than. So dotted line here and a dotted line here. Okay, and then we have to shade for both of these. Sorry, I probably should have shaded the purple one right away. I didn't do it. So for that purple line, we have, if we plug in 0, 0, 0 is less than or equal to 0 plus 2, and 0 is less than or equal to 2, so we can shade on the 0, 0 side for the purple. Okay, that's going to look like that. For the green one, if I plug in 0, it says 0 is greater than the absolute value of 0 minus 3 plus 1. So 0 is greater than, -3 absolute valued is 3 plus 1. And 0 is not greater than 4. So we're not going to shade the 0, 0 side. We're going to shade here instead, which means my answer is that chunk. Okay. Next one, this one's kind of fun. I like this one. We have y is greater than the absolute value of x minus 1, and y is less than the absolute value of x plus 3. Okay. Remember when the plus and minus is outside, that's just moving up and down. So it's V-shaped, and we're moving up and down. So for the purple one, we're moving down 1 from 0, 0, and then our slope is up 1 over 1. Okay, so we take a straight edge and we draw those lines in. These are dotted, right, because it's greater than, it's not greater than or equal to. So a dotted line there and a dotted line here. Okay, and then the green one, we have plus 3, so 1, 2, 3 is our y-intercept, and still a slope of 1. And again, this is a dotted line. Just going to freehand this one. Dotteds are a little easier to do that with. I didn't do it well. And now we have to shade. Okay, so if y is greater than, if I plug in 0, 0 on that one, basically I'm saying 0 is greater than the absolute value of 0 minus 1. So 0 is greater than -1. True story. So that's going to be shading above this one. Okay, then the green inequality says 0 is less than the absolute value of 0 plus 3. So 0 is less than 3. That is true, so I want to shade the 0, 0 side for the green one. So that one is going down below the green. And you'll notice the only overlap is happening right in between them. So pretty, right? Okay, so that's number 4. Then, let's get my ruler out of here. This next one, it says solve the system by substitution. And you have a lot going on here, right? We have A equals AC. We have B equals 2C. And then we have A minus 3B equals -8. Okay, so I know what A equals in terms of C. So I'm going to plug that one in here. And then B in terms of C right here. So when we plug that in, we get 8C minus 3 times 2C equals -8. Okay, now simplify that. 8C minus 6C equals -8. So I get 2C equals -8. Divide by 2, and C is -4. Okay, so there's our C value, which makes A and B really easy to find because we can plug that in right here, and we can plug that in right here. So A equals 8 times -4, which means A is going to be a -32. That should be a 3, not a 2. And then B is 2 times C, so 2 times -8, so B is -16, which means if we wrote this as, it's not a point, but as coordinates, we would do -32, -16, -4. And that is our answer. Those are so fun. I love those. Just love them. Okay, then we have number 6, which is solving by elimination. And you should notice here, okay, right off the bat, you have some opposites with your z's with no coefficients. So that's what we want to work on here. So what we're going to do is we are going to start with the first 2 equations. Okay, so my first equation here is 2x minus 2y plus z equals 1. And then my second equation is 5x plus 4y minus z equals 1. Okay, so if I add these 2 together right now, I can say that 7x -2 plus 4y is a positive 2y. This zeroes out, equals 2. Okay, so here's an equation that comes from 1 and 2 being eliminated. Okay, then I can do 2 and 3 and eliminate my z's that way. So now I'm going to say from equation 2, which is 5x plus 4y minus z equals 1, and equation 3, which is -x minus y plus z equals 2. Okay, I can add those together. So 5x plus a -1x is 4x. 4y plus a -y is a positive 3y. Those will zero out, and we're left with 1 plus 2 is 3. Okay, now I'm going to take those 2 equations, so the one that's boxed in blue and the one that's boxed in purple, and I'm going to do elimination with those. So if you look at what we have here and here, to eliminate, I am going to multiply, let's see, I will multiply the top equation by 3, and I'll multiply the bottom one times -2. Okay, so take that down here. If I multiply this top one by 3, I get 21x plus 6y equals 6. If I multiply this one by -2, sorry, I get -8x minus 6y equals -6. Okay, now we simplify from here. we're going to eliminate our y's. So 21x plus a negative 8x is 13x. This is 0. 13x plus 0 is just 13x. And then 6 plus a negative 6 is 0. So I get 13x equals 0. I'm going to divide by 13, and I get x equals 0. Okay, so now I know what x is. And now I can plug that back in to my 2 up here that I did earlier. So I'm going to plug it in here or here to solve for y. It doesn't matter which one. I'm just going to plug it into that second one. So if I plug that in, it's going to be 4 times 0 is my x plus, so I'm doing this one right now. 4 times 0 plus 3 times y equals 3. So really I'm getting 3y equals 3 because this is 0. Divide by 3, so y is 1. Okay, so now I know x is 0, y is 1, and I just need z. So come back up here to our originals. I would plug it in right here. So I have a negative 0 minus 1, which is my y, plus z equals 2. Well, negative 0, that's just 0. Minus 1, I'm going to add that 1, and we get z equals 3. So my answer is 0, 1, 3. Ooh, that's a doozy, huh? So fun. I love those. Okay. Number 7 says, write a system of equations to represent the situation and solve the system. Last one. Okay, so this one, we are doing a money thing again. It says a change machine contains nickels, dimes, and quarters. Okay, there are 75 coins in the machine, and the value of the coins is $7.25. There are 5 times as many nickels as dimes. Find the number of coins in each machine. So first of all, it says there are 75 total coins. So I know that nickels plus dimes plus quarters should equal 75. Okay. I also know the value of all of those. So a nickel is 5 cents, so 0.05 times the number of nickels. A dime is 10 cents, so 0.1 is fine, or 0.10 if you want to have the 0 there is fine. And then a quarter is 25, so 0.25 times Q. And then the total is 7.25. Okay. And then the last statement is right here. There are 5 times as many nickels as dimes. Okay, so that means the number of nickels is 5 times the number of dimes. Whew, lots going on. Okay, here's what I would do first, just because it's not as pretty to work with decimals like this. The first thing I would do is I would take this whole equation and multiply everything by 100. So you get 5n plus 10d plus 25q equals 7.25. You don't have to do that, but I think it makes it way easier. Okay. So then, okay, the second thing that we're going to do is we're going to substitute n in both equations. Okay. I know n is equal to 5d. So that's what we know here. So I'm going to take out the n's, and I'm going to put in a 5d. So I'm going to take this equation, and I'm going to put it here substituted. Okay. Actually, let's just separate that. I'm going to go a little bit lower so we're not throwing you off. So I'm going to say 5d plus d plus q equals 75. Okay. Then I'm going to substitute my 5d in place of n here as well. Okay, so for this one, this is going to be 5 times 5d plus 10d plus 25q equals 725. So I just substituted right here. That works out to 25D. Okay, so I'm just gonna take out this 5 times 5D and call it 25D. Okay, now if we simplify again, 5D plus D is 6D plus Q equals 75. Simplify this one, I get 35D plus 25Q equals 725. Okay, you with me so far? Lots going on here. So then what I would do is now I would try to eliminate in that system. Okay, the way I can do that is I can multiply this top equation by negative 25. So when I do that, I'm going to distribute that negative 25. Here's what I get. I get a negative 150D. Okay, that's 25 times 6, negative 25 times 6, minus 25Q equals, and then 25 times 75, that's a negative 1875. Okay, but then I also still have this equation, 35D plus 25Q equals 725. Okay, so I'm going to eliminate my Q's here. So if I add these together, I get negative 150D plus 35D. So that's a negative 115D. This zeroes out, equals negative 1875 plus 725 is a negative 1150. And then I'm just going to divide by negative 115. So I get D equals, and that comes out to 10. Okay, now go back up to where we started. We said N equals 5D. So I can find N right now because N is equal to 5 times my D, which is 10. So N is 50. Okay, now I have N, I have D, I just need Q. The way we're going to find that is we're going to plug back in. I would plug it into that first one. So N, which is 50, plus D, which is 10, plus Q, which we don't know, is 75. So we're going to take 60 away to make that zero out. And you get Q equals 15. Okay, so the question is, find the number of coins of each type of machines. That means we have 50 nickels, 10 dimes, and 15 quarters. Whew, that's a lot, huh? So fun. I love it. All right, that's all I got for you.